A formula for the relationship between the weight and the blood pressure in the children is given by this, which is P of x is equal to 13.9 times 5 plus ln of x. And this formula is valid between 10 to 100 for x. And remember here the weight is x and the blood pressure is actually P of x. So we have the relationship between those given by this formula. And P of x, the blood pressure is actually measured in millimeters of mercury, and x, the weight, is measured in pounds. So this is just the given information. The question begins here. So our goal is to find the weight. So our goal is to figure out x at which the rate of change of the blood pressure with respect to weight is 0.7 millimeter of mercury per pound. So our goal is to figure out x at which rate of change of the blood pressure with respect to the weight is 0.7. So how to model this? So let's try to formulate this problem. So let's try to write down the given information. We have given P of x, right? It's a blood pressure, which is and the relationship between that with the weight, which is 13.9 times 5 plus ln of x. So this is the formula we have given. And what do we need to figure out? We need to figure out the weight, right? So we need to figure out the weight. Okay, so it looks like our goal is to figure out what is x. All right, but what is the condition? We need to figure out the weight at which the rate of change. So that means we need to figure out x equal to what when the rate of change of the blood pressure. What does it mean by the rate of change of the blood pressure? How do you figure out rate of change of any function in calculus? By using the derivative, right? So we need to figure out the weight, which is x, when p prime of x, that means rate of change of the blood pressure with respect to the weight. So p prime of x to the weight is rate of change of the blood pressure with respect to the weight is 0.7. So we need to figure out x when p prime of x is equal to 0.7. Okay, so this is the question. Okay, so we have given, then since we have already extract all of the necessary information, so let's just focus on this one. So we have given P of x equal to 13.9 times 5 plus ln of x. Our goal is to find x, right, when p prime of x equal to 0.7. So how do you do that? Well, to find x, then it looks like we need to see where this equation is satisfied. To do that, we need to first find out what is p prime of x. So let's do that first. So if p of x is equal to 13.9 times 5 plus ln of x, let's just first find what is p prime of x. So let's find p prime of x. How can we find this? P prime of x can be figured out by using the constant multiple rule, right? Why? Because we have a constant multiplied by some function. So if that is the case, write down the 13.9 as it is, multiply by the derivative of 5 plus ln of x. So let's differentiate 5 and let's also differentiate ln of x with respect to x. Okay, so this is then equal to 13.9. What is the derivative of 5? 5 is a constant, so the derivative is 0, right? Plus, what is the derivative of ln x? We have the formula. The derivative of ln x is just 1 over x. So if that is the case, 13.9 over x is the p prime of x. That means the rate of change of the blood pressure with respect to x is 13.9 over x. But so if this is p prime of x, then our goal is to see, right, when p prime of x will be equal to 0.7 for what x value. So that's what the main question is. So if that is the case, let me replace p prime of x by 0.7 over here. So if that is the case, then I will get 0.7 0.7 is equal to 13.9 over x. If I solve now this equation, then I will get the value of x that will satisfy this given equation. That means I will know for what weight the rate of change of the blood pressure is 0.7. So how do you solve this equation then? This is like a rational equation, right? So how do you solve any rational equation? We multiply both sides of the rational equation by the lowest common denominator. So when you do that, on this case we get 0.7 x is equal to 13.9 divided by x multiply by x. So x and x cancel out, so we get 13.9, right? And this is like a linear equation. Now to solve the linear equation, we can just, on this particular one, we can just divide by 0.7 on the both side. So if we do that, then we get 13.9 divided by 0.7, and this is approximately equal to 19.857. And what was the unit of the weight? Pound. So we can write down this as the required answer. Okay, so our goal is to figure out x, right? So and then this is, we satisfy that condition, p prime of x equal to 0.7. so this is the answer. But if you want to round to the nearest pound, then this can be also written as, so the nearest pound would be, what would be the nearest pound? So 20, right? So if you want to write down that, so nearest pound, if you want to, nearest, nearest, okay, round to the nearest pound, round to the nearest pound. If that is the question, then 20 is the answer. Otherwise 19.857 is the sufficient answer.